Our video today is on the superposition of waves. When two waves reach the same point at the same time, the particle that they reach is affected individually by the waves. The waves don't interact at all. For example, let's say this is the point, right? My hands are going to be the waves. This is a point. The waves come together at this point, right? At this point, the waves essentially work together to move this particle. They don't merge together and move this particle. They go together like that. Here you can see example. See how the two waves come, they join together to move the particle, and then they continue on their separate ways. Now, if you have two waves of the same nature, okay, but they have slightly different frequencies, the phenomena that appears is called beats. What beats are, as I said, two waves of the same nature that have slightly different frequencies. So, for example, it might look something like this. Wave 1 and wave 2 coming together at this spot. It would be called beats. What you need to know about beats is that there are two formulas. The first one, if I have a pencil, says that the frequency of the beats is equal to the absolute value of F1 minus F2. So the frequency of each of the waves subtracted from each other in absolute value. And as always, period is equal to 1 over frequency. So that is what you need to know about beats. Now, if two waves of the same nature have the same frequency, then we call them interference. There's two different types of interference waves. There's constructive and destructive. Constructive is when both of the waves have the same sign. So the amplitudes have the same sign. So let's say wave 1, right, is at a positive amplitude right here. And wave 2 meets it also at a positive amplitude. Because they're both at positive amplitude, we call this constructive. Now, if they were to meet with opposite signs, right? So one of the amplitudes is positive, like this one right here, and the other one is negative, like this one right here. So they meet, right? Let's say we can call it the same point, just with different signs, and we say it's destructive. Okay? So there are ways to figure out whether a point is on a constructive fringe or a destructive fringe. Let me draw out actually something for you. We'll call this one right here source 1, and this right here source 2. So these are two sources that are releasing waves of a same nature and same frequency. So the phenomenon that we're going to observe is going to be interference. Just make sure that's focused. Okay, let's say we have a point right here. We're going to call it point M. So one thing we can notice about point M is that it's closer to S2 than it is to S1. But if we want to find out if it's on a constructive or a destructive fringe, there's two different formulas that we have to apply to figure out which one it is. The first one says that MS2, which is the distance between M and S2, minus MS1, which is the distance between M and S1, is equal to K lambda. So K, first of all, belongs to Z, which is integers. So it's -1, -2, -3, 0, 1, 2, 3, basically not a decimal. It can be positive or negative. If K belongs to Z, then the point is on a constructive fringe, meaning the wave that is being moved by is constructive. So the two waves are meeting. Well, they have the same sign. Now, if MS2 minus MS1 is equal to 2K plus 1 times lambda, where K belongs to Z, if K belongs to Z, then it is on a destructive fringe. Okay, So if you're trying to figure out whether point M is on a constructive or destructive fringe, this is probably one of the fastest ways to do it. So fringes, one important thing to know about fringes, let me just draw it. Actually, let me just rip out another paper. One important thing to know about fringes is that, let me draw another diagram for you. S1, S2. So all the fringes in between these are going to have numbers, and the numbers are always going to be the same. Constructive fringes are always one more than destructive fringes because the midpoint between these two is always going to be a constructive fringe. So these 2 points are, let's call it 7 centimeters away. So 3.5-ish is the midpoint between them, meaning at 3.5 we have our first constructive fringe. This fringe is called K is equal to 0, so it's at order 0. Now, one destructive fringe over on either side, right? There's always a destructive between 2 constructives. Let me just, okay. So because we use the formula ms2 minus ms1 to find the, let me remember what it's called. To find the path difference, right? So ms2 minus ms1 is called the path difference, right? Because we use ms2 minus ms1, all the numbers on S2 side are going to be negative, and all the numbers on S1 side are going to be positive. So we're going to start with the constructive, just to make this easier. Let's say there's 2 on either side. Okay, so K equals 0 here. If you move over 1 close to S1, it's going to be positive, because remember we said this side is positive and this side's going to be negative no matter what, because we use ms2 minus ms1. If we were to reverse it, then the sides would be reversed. So what's one number higher than K? Than 0. It's K equals 1. So the first constructive fringe after K equals 0 is K equals 1. The next one is K equals 2. And you just continue out 1, 2, 3, 4, 5, 6, 7. You're just counting them essentially. But then on this side, we do the same thing except with negative numbers. So K equals 1, the first constructive fringe, minus 1. K equals minus 2, and you're just going to keep moving on for every single constructive fringe. Now, destructive fringes are the same way, except obviously it's not in the midpoint, so finding 0 is a tiny bit more difficult. What you need to do, you need to locate K equals 0 of constructive fringes. Okay, so that's this one right here. And you move 1 over to the side of S1, which is this side. So this one right here is going to be K equals 0. So then let me just draw this right here. Okay, this one is going to be K equals 1. And if there's 1 right here, which I'm not going to place 1, it would be K equals 2, and so on and so forth. We do the same thing on this side. So this side, so K equals 0 is this one. So this one right here is K equals minus 1. And this one right here is K equals minus 2. So that is what a figure of fringes would look like, right? So there's a formula for you to figure out how many constructive or destructive fringes there are. And that formula says that n minus 1 times lambda over 2 is always going to be less than or slightly equal to S1, S2, which is the distance between the 2 sources. If n is an even number, then you found yourself the number of destructive fringes. If n is an odd number, then you found yourself the number of constructive fringes. Now, there's one more thing to learn, and that is about standing waves. So the one difference between this and interference is that standing waves not only have the same nature and frequency, but they also have the same amplitude. And, oh wait, actually before we do that, let me tell you one more thing. So the distance between one constructive fringe to its consecutive constructive fringe is lambda over 2. The distance from a constructive fringe to its consecutive destructive fringe is lambda over 4. Now, back to standing waves. If we said that they have the same amplitude, right? They're waves of the same nature, same frequency, and same amplitude. If it's a crest and a crest at the same time, or a trough and a trough at the same time, then the point of max energy is called an antinode, which are these points that you can see right here. If you have a crest and a trough meeting at the same time, then it's what we call a node, the point of no energy. So the distance between, let me draw this out really quick. Oh, I have it drawn right here. The distance between an antinode and its consecutive antinode is lambda over 2, and the distance between an antinode and a node is lambda over 4. So let's do a quick revision. Oh, one more thing. Constructive waves, So constructive waves, when you have constructive waves, the amplitude that you get is equal to amplitude 1 plus amplitude 2. If you have destructive waves, the amplitude, that is a D, amplitude is equal to absolute value of A1 minus A2. So now we can do a quick revision. Constructive waves, they're in phase, essentially we can call them in phase. We can find them by that. The amplitude is A1 plus A2, and we can find it by using ms2 minus ms1 is equal to k lambda, where k belongs to z. Destructive waves are in opposite phase, or similar to being in opposite phase. The amplitude is the absolute value of amplitude 1 minus amplitude 2, and the way to find them is by proving that ms2 minus ms1 is equal to 2k plus 1 times lambda over 2, where k belongs to z. The distance between consecutive constructive and destructive waves is lambda over 4. The distance between consecutive constructive and constructive, or destructive and destructive waves, is lambda over 2. We have this formula here, n minus 1 times lambda over 2 is less than or approximately equal to S1, S2. N is the total number of fringes, and if n is odd, then that's the number of constructive fringes. If it's even, then it's our number of destructive fringes. Essentially, the difference between k and n is that k is the location or the name of one fringe, and n is the number of fringes. Beats are when their frequency is slightly different. And the frequency is the absolute value of f1 minus f2, or the frequency of the first wave minus the frequency of the second wave. And the period is, like all other periods, 1 over the frequency of the beats. Standing waves are waves that have the same nature, same frequency, and same amplitude. It's a specific constructive destructive case. The point of a crest and a trough meeting is called a node. The point of two crests or two troughs meeting is called an antinode. When the wave starts at a fixed end, it starts at a node. When the wave starts at a free end, it's an antinode. That's everything.